All right, question 61. We have a projectile launched horizontally from a cliff and it hits the ground. So when you launch things horizontally, the horizontal component of velocity never increases. It remains constant. However, as it's falling, it's gaining speed, and that's how we get choice B. 62. Constant velocity in a straight line. What's that free body diagram look like? Balanced forces. A lot of people want to draw this one. Don't forget there's left and right forces that need to cancel too. Like these two are clearly wrong. This looks like a contender until you realize that there's horizontal forces happening as well that need to cancel. All right, and the moon orbits the Earth as shown, and we want to know the forces acting on the moon. So once again, it's moving in a circle. So we're going to have this gravitational pull going towards the center, which is choice B. Same idea. Going in a circle, the force is directed towards the center of the circle. Now here. Pendulum bob swings here. It catches on a peg. We want to know how high up it goes. Do not let the peg fool you. We're still dealing with conservation of energy. So we're going to swing back up to the same height as we started with. So that's question 64. Question 65. Oh my gosh, car collides in the more massive truck. How do the forces compare? Equal, equal, equal. I hope these are getting a little more comfortable for you where you're seeing things repeat. Again, they're always going to give you a massive truck. They will make this to a ridiculous extreme. Like a little tiny bug crashes into a big rocket or whatever. We deliberately throw that phrasing in there to throw you off. Don't let it fool you. All right, two identical blocks connected by a light cord on a friction surface. Once again, it's the two block problem. Remember, the force here is going to be less than the force here, so that rules out the possibility of C and D. We can't have a zero force, so we know it's 1/2 F, but let's actually figure this out. So I've got F is twice the mass times the acceleration. The acceleration is F over 2m. So this chord here, which I'll call F2, well, F2 is just plain old m times a, m which is F over 2m. So when we cancel, F2 is actually half of the original force. All right, 67. Here we get two forces. We want to know the magnitude when they combine. So let's be clear. We're going to have F sine 45 here and F sine 45 here. So in this direction, the two forces cancel. Horizontally, though, we've got F cosine 45 from one boat and F cosine 45 from another boat. So the total towing force is going to be 2F cosine of 45, which is going to be 2F square root of 2 over 2, which is choice D. So that's question number 67. And continuing with question number 68. Once again, we want to graph P versus 1 over V. You know what? We're going to skip number 68. We could almost get it, but it's not quite. I would want you to know a little something about ideal gases before we start this. That's what I would say. Question number 69. A woman parachutist jumps from a plane. After free falling for a short while, she opens her parachute, lands safely on the ground. So what's going to happen is, first she's going to gain speed, and then her speed's going to level off to a constant, and then it's going to drop to 0. So is there anything that captures that? Oh, actually what happens is she gains speed, then the chute opens and she slows down, then she coasts at a steady speed, then she stops. So that's choice C. So speed up, chute opens, slow down, there you are at terminal speed, and then you hit the ground. Finally, number 70. A ball is dropped on a horizontal flat surface, and we want to know the magnitude of the acceleration. This is really important. A lot of people, I saw this on your last test, 20 minus 1, 2.0 minus 1.5 is 0.5. No, careful. Downwards, I'm going at negative 2.0 minus positive 1.5 going upwards over the time. And that's how I'm getting 35 meters per second squared. So this is negative v down, positive v up. So it's negative v minus the positive v up. Oops. I just crossed that. So that's the idea. All right, so that's questions 61 through 70, and we'll continue.